Well, so here we are. This is the advent of code of 2019, and this is the first day that I already completed, but I want to make it again so I can explain some things about the Rust language, which is a new language, well, 4 years old language that not many people know about, and I think it's really cool because it offers you really fast performance with some type system that actually allows you to express many things in a quite nice way. So let's go for it. Okay, this is the description of the exercise, and uh, as you see here, this is quite long and boring, so we're gonna go to the point. This exercise is asking us to implement a function that, given some mass, returns some field. Okay, here specifically they tell you how you need to implement it mathematically. Here you got some examples which basically are test cases, and I think we're gonna take advantage of that, right? So we got some test cases and we can do TDD, right? Quite easy. So let's go for that. We're gonna create a new cargo module called day1bis because day1 I already did it, and here we see that something is going on, which is hello world. Okay, if we do test, which is something we are really interested, it's gonna see zero tests are run. So let's change that. So opening the folder, we got some main file, and the first thing we're gonna do is implement a module for test. Okay, I'm gonna say that this module is gonna be only valid during test. This is done by CVG test, and here we are gonna implement our first test function, which is gonna be called very clearly test. Assert that true is true, and it's working. Okay, it ran one test and the test is okay. So since we want to transfer we get the field from mass, I'm gonna call the test actually field from mass. I'm gonna put a function here called field from mass. Wow. Since the function is gonna take some integer and return some integer, I'm gonna reflect this in the type of the function, and by now I'm gonna return 0. Okay, so I'm gonna put the test case, which is taking 12. We should return 2. And if I run the test, it's gonna fail. The thing is, it doesn't fail because the numbers are off. It fails because it doesn't see the function, because we didn't put it on a scope. This is a different model, so we need to import the function in order to work. For this, we're gonna refer to the parent module, and we're gonna import the function. Okay, right now it's working, running one test, but the result is wrong. If I do 2 here, which is obviously not correct, but it works, we got the green. Okay, let's then put another test case, which is gonna be 14 as actual value or input value, and 2 is the expected value, the same thing. So it's gonna work because we didn't change it. Because we are gonna test execute this test function a lot, I realize we can do cargo watch. and this is gonna change when we save the file. So let's put the third test case here. It was what, 1969, and the expected result is obviously this is gonna fail, right? Because we didn't implement the function, but we can do it now. Let's basically follow what is saying here. So we need mass divided by 3, and then we need to run down, which is already done for integers, and subtract 2. Go to this. What do we got? We got pass. Then let's go for the last test cases. Okay, we got input here, we got expected value here, and it's done, so we don't need to do anything about it. The function is correct. Okay, let's follow the description of the exercise. So it needs to know the total fuel requirement, and for this we need to get the mass for each module, which we will find in the puzzle input, and this is what we got here open. So let's put this in Rust. I think this is the easier way to do it, right? Because we don't need to mess with files and stuff like that. We don't need this. Is a very dumb exercise, so let's not waste time on it. Let's just replace all the end of line characters in a very dumb way. Already overshot. Okay. So let's see what's going on. It says that it doesn't have type, of course. This is an array. So let's declare it is an array of 264. I don't know how many. Let's put 2. Let's say it's not 2. It's 100. So let's write 100 here. Okay. Since the formatting is so horrible here, I'm gonna fix it very fast by doing what? By doing, I don't know why I have this. Okay. By doing cargo fmt. Okay, now it looks better. I think I realized the pain I had before is because I maxed out one pane and I forgot I had other pane running in the background. Okay, no problem. So let's process the input with some iterator, right? Let's do it the functional style. We got the iter. I'm gonna because the iter gives us reference. Here we get values. We're gonna clone each reference to treat as a value. Then we're gonna map our function. And then once we got all the values, we need to basically reduce the array, or accumulate, or fold, which is how Rust calls it. So the accumulator value starts with 0. For the adding function, we got the accumulator here, we got the val here, and we used to this. Let's print it. It's the first part of the exercise. We got the result. Okay, format it again. Much nicer. Okay, I realized since this is a very basic function, this is already implemented in the standard library, so we can use it. And we skip the closure. like that. Just to make sure we got the same result. We got it. Okay. Let's check that this is the correct answer, and it is. Then let's go for the part 2. So here in the part 2, we say that okay, we got the mass, the field, but the field also has some mass, no? And the equivalence established in this description is that one field has one mass. So we need to calculate, or we need to take into account the mass of the field to calculate the mass of the model. Okay, this is screaming recursion. Okay, the first time I did it with the recursion, but since I'm repeating myself, I can do it in another way. I will show later how did I do it with another loops-based solution. So it says here that you need to put the field mass as input value and repeat until a field requirement is 0 or negative. Okay, this looks very easy, and we got here test cases also. Let's start with that. Let's create another test function. I'm gonna call it test field from model, differentiated from the previous one, and I realized in the first test case is actually this one. I'm gonna put it in scope, and of course I'm gonna implement it. The first implementation is gonna be SuperDOM, which is gonna be calling the other function, and that's it. But with this, we got some path already. So let's go for another test case, right? Okay, here it says that the input is 1969 as before, but the output is not this, it's gonna be 966. And once this runs, it's saying, of course, this is not okay. Then let's fix this. Okay, fuel equal that. Then it's saying if fuel is less than 0, then return 0. But if not, we're gonna return fuel and fuel from model again. And once I save this, oh, Stack Overflow, I'm doing something wrong. Yeah, it's gonna be fuel from fuel. And now the test pass. Got the green. Let's put the other case, which is input that, output this, and let's see what we got. We got green again. Good, it looks like we already implemented. Then let's check what we need to do. It's the sum of the field requirements from the input again. Okay, this looks like copy paste. Good. It's cool that you can actually redefine a symbol in Rust. The way it works is basically it ignores the others value you got here already. So at this point, this total field is distracted. We can say, and here we create a new one. So the difference is gonna be we use this function in order to check the result. We run it. And here we check that the answer is correct. Alright. So as I said before, I implemented this this exercise, and it's actually quite easy one. So I can basically show you the other way I did it. Just this way. It's a loop-based solution, which for us is, I guess, more convenient. You just need to use a bit of mutability, but I don't think there is tail recursion, tail call optimization in Rust, so this is the safest bet I will guess in order to get some performance. So basically, the difference is in this function I make mass a mutated variable, and when mass is more than 0, I'm gonna calculate the fuel from the other function, from the mass. I'm gonna add the fuel to the result, and I'm gonna say that mass, the new mass, is the fuel from before. And that is also doing the same, basically, without abusing the call stack, of course. Another difference is that we don't use clone here, because I didn't know at that moment. So as this is a reference, you can see here, we need to dereference this before calling to the function. So it's a bit more noisy, but maybe a bit more clear. Also. Anyways, that was all. Let's look forward for the day 2. Bye bye.